So, welcome everyone. This is the part one of Olas Dev Kickstart 2. So, this is the second time we are having the Kickstart. And this time we are dividing in 3 sessions so we can do everything a little bit more slowly. And I'm gonna give the space for David to start presenting. Thanks everyone for joining.
All right, let's go then. Before we start, I think I should read the usual disclaimer. So this session is organized by Valerie in order to educate people about OLAS and developing autonomous services. Valerie is one of the core contributors to the OLAS ecosystem, and all the content we provide here is an expression of our view and therefore does not constitute financial advice. With the disclaimer out of the way, I think we can start already with the Olas Dev Kickstart 2 part 1. You know that this series of academies will basically take 3 different days. So today is the first day, and let's start with what we'll cover today. So first, we'll present ourselves. We'll talk about who we are. We will explain what the goal of this Dev Kickstart is, and then we will cover a short intro to OLAS for those that are not sure about what OLAS is, what autonomous agents are, and then we will discuss about Mech and Mech tools. And we'll start with our first lab session about using the Mech client, which is a Python library, to send a Mech request. Then we'll have some time for questions and answers, and then you will have some homework that you will need to prepare before tomorrow. All right, maybe we can start presenting ourselves. Carol, you want to go for it?
Yeah, of course. So I'm Carol, product manager here in Valerie. I am responsible for the Dev Academy and the developer experience. Before that, I've been in Web3 for about 3 years now. All this time in community, dev relations roles, marketing. And prior to my Web3 experience, I worked as a program manager and account strategist for Google and Facebook, now Meta. And I'm also a qualified lawyer. So many different carols here.
Yeah, and I am David B., one of the senior software engineers at Valerie. Also founding member of Olas DAO, and my background was in mechanical engineer, where I hold a PhD. But now I have been repurposed as an engineer. I think in the call we also have Jose. I don't think we have a slide for him, but maybe Jose, you want to introduce yourself as well?
Sure. So I'm Jose. I'm also an engineer at Valerie, also a founding member of the DAO. And yeah, my background is on security, cryptography, and I'll also be around in case David needs my help.
All right. So then, what's the goal of these presentations, of this series of developer Kickstarts? So the idea behind this course is to make it easy for everyone to contribute code to OLAS for a chance to start earning dev rewards. So the idea is that we give you the tools to contribute to some code to the OLAS ecosystem, and that will give you the chance to earn some OLAS rewards. So first of all, we need to talk about what is OLAS. I think Peanut has already asked that question. And yeah, basically, OLAS is many different things. And we usually like to think of OLAS as a 3-legged stool. Basically, OLAS is a protocol, but also it's a stack and an ecosystem. So basically, the protocol is an autonomous agent focused protocol. We will cover what an autonomous agent is in a second. But basically, we have this stack to create these autonomous agents. Then we have the protocol to incentivize these agents, and also devs like you to contribute code and to create new agents. And then all this rich ecosystem of different services and agents running and creating value is also part of Olas. So Olas is live and has been deployed across 8 different chains, if I am not mistaken, being them Ethereum, Gnosis, Polygon, Arbitrum, Solana, Cielo, Optimism, and Base. And since the last almost 2 years, all these agents that we have deployed, I think we have more than 800 agents already. They have produced almost a million transactions across all these different 8 chains. So that's very good, but what the hell is an autonomous agent? So basically, when we talk about autonomous agents, we think of them as applications that have wide applicability. For example, we can use autonomous agents as oracles, as backend automation tools, DAO tooling, messaging, and relayers, and also, of course, the king here, AI tools. These agents are unique, powerful, and implement novel capabilities. We usually show this diagram here where we compare the existing solutions previous to autonomous agents. Basically, traditional services like web services, we usually say that they are flexible and kind of intelligent, but they are not crypto native. Then we have the all reliable smart contracts, which are very flexible and also crypto native, but they cannot take action on their own. So we say they are not intelligent. And then we also have another custom ad hoc automation and oracles, which are crypto native as well and kind of intelligent, but are not very flexible. So we like to think that autonomous agents and services are something in between that lets us basically being crypto native, but also intelligent and flexible as well. And this lets us implement applications in very different ways where we can interact with not only the on-chain world, but also with the off-chain world. So these agents and these services can pull data and push data to Web2 services, also interact with databases, APIs, and so on, but also create transactions on chain, which makes them uniquely powerful. This lets us configure these kind of agents in different ways. For example, some people might be only interested in running a single agent. This is what we call a sovereign agents that are lightweight and anyone can run it on their machines or their services, And basically the kind of people that runs a single agent are not concerned about decentralization or fault tolerance, but they are concerned about having this freedom of having an agent interacting with all the on-chain and off-chain world. But then there's another kind of people who are more concerned about decentralization or fault tolerance. And then with Olas, you can also configure these agents as multiple instances that work together in consensus and democratically selecting what's the next action to make or to take. So basically, you can have a service run, for example, like here in this image, by 4 different people running each one agent. But you could this not for 4, but you can this for 40 or for 400. And this lets us create complete agent economies where both sovereign agents and decentralized agents thrive and share services, one consuming services from each other, while at the same time offering their services to other agents. There we go. And how is this possible nowadays? Well, basically, all these autonomous agents are implemented as what we call autonomous services. This is a high-level architecture of what an agent service look like. So let's go box by box and see what each box is. Basically, let's think of an agent service made up of n different agents. So these n different agents here represented as blue boxes are run by n different people. For example, I see we are 12 people now in the call, so we could have 12 people, each of us running a single agent. So we would have a total of 12 agents, and these 12 agents would be connected by these green boxes here called consensus gadget node. Basically, this means the name is not that important now, but the important thing is that all these different agents run by different people are connected, forming a unique network similarly to a blockchain. So whenever the agents need to take action, for example, prepare and send a transaction, they first need to use this consensus layer to decide what's the next step, or if this is a transaction, what the next transaction is going to be, then sign this transaction and send it to either blockchain 1 or blockchain 2. Maybe this was not a transaction. Maybe this was some pulling data from an API. Whatever you can think of, you name it, you can do it with an agent. Basically, not only interacting with multiple blockchains, but also with databases, APIs, and whatever you can think of. So the point of this is that once you have a single service like this offering and consuming services from or APIs or data from other services, you can start connecting all these services one to each other, as said previously, where basically one service consumes the data from one other agents. At the same time, this one can offer data to this other one. So we end up having a complete economy where all these services connect, not only Web2, they basically can interact with IPFS, with Starknet, with Solana, Ethereum, Ceramic, everything that we can think of can be connected with this kind of agent services. And yeah, this is kind of abstract so far. So let's talk a bit about one of the most popular agent services we have running on production, which is the Mech, and which will be the core of these calls. Basically, AI Mechs are several agents that are running now on production that take requests from both end users, can be humans or even other agents. And these AI Mechs serve as a hub where people and agents can send some requests for this Mech to perform an AI task. And then the Mech will deliver the result. For example, we are now seeing a lot of new LLMs like ChatGPT or Anthropic that people uses nowadays for the applications. So both humans and agents sometimes need to interact with these LLMs. And the traditional way of doing this is through their APIs or their applications. But this requires you to know, A, how their API works, and B, you need to have a API key. So basically, you need to pay a monthly fee to access, for example, ChatGPT. The idea behind the AI Mech is to abstract all this away from users and other agents. So you can basically use this as a unified interface where you send a request to the Mech on chain, and the chain will deliver the result in exchange of a small payment. So basically, this is it. The Mech is deployed as a decentralized autonomous agent. We have several Mechs deployed across several different networks. And we could even have different Mechs on the same network as well. And the Mech will serve as an AI delegator. Basically, all these interactions, all these requests and response will happen on-chain for security purposes and decentralization purposes. And that, as I already said, this can be thought as a unified interface that abstracts all the complexity of different APIs from the user in exchange of a very small payment. This avoids users from having to learn a different API for each service. basically you use the same with Mech. You always use the same API for everything. Either you want to interact with ChatGPT or with Claude or with any other LLM or other service, Google or whatever. You use the same Mech API for everything. You do not need to manage any API keys, and therefore you don't need to pay for a monthly subscription. And then, of course, you also don't need to handle any infra to execute these complex AI tasks. Not everyone has a handy server at home where they can have like a couple of GTX cards or RTX cards that are really expensive. So let's talk about a more concrete example on how we are using Mechs. And this example is the prediction markets. Prediction markets are a type of markets where instead of people trading, let's say, tokens, they basically trade predictions. So let's say someone asks a question that can be answered with a yes or no answer. For example, maybe I want to know whether ChatGPT 5 will be out before the end of the year. Some people like trading on this kind of prediction markets, and some people will basically bet on the yes. Some people will bet on no, and there's a complete different prediction market platforms out there where you can do this, and they are pretty popular. One of them is Omen. Omen is one of this kind of prediction markets that we interact with. So here you can go and open your markets. So basically this entails coming up with a question that can be answered with yes or no, and then people will trade on that question. So we have one of our agents, which is the market creator, parsing the internet for news and interesting data that it can use to create new markets on the Omen platform. And then there's a lot of people running trading agents that will read all these new markets on Omen and will trade on what they think the outcome of each questions will be. Basically, they will be trying to predict whether a future happening will be, well, something in the future will happen or not, basically. So usually a trading agent would need to parse the web as well and try to use some models or some strategy to try to answer these questions. But happily, we have the AI Mech for this. So as I said, the AI Mech will offload all these tasks away for this kind of trading agents or even humans. And basically what we do with all this, I think we have like 500 or 600 different trading agents now deployed. And every day, these agents will read these questions on Omen, opened by the market creator. And whenever they find these questions are interesting, they will send a request to the AI Mech, something along the lines, all right, I have this question, and I want to know what's the chance for this happening or not happening. And I want you, Mech, please, to use ChatGPT to try to figure this out. Or maybe I want you to use some Google LLM or some Cloud LLM. So the trading agent will send this request with the prompt and the tool that or the LLM name that it wants to be used. And then the Mech will receive it and will run this request against the, for example, ChatGPT API, and will send back the response so the trading agents can finally put a bet on the yes or the no. This is a bit more complex than a traditional API request, where you basically send a request to the API and you get a response back. But given that this happens on chain, this has to be a bit more complex, although happily for you, you don't need to know about this. I just want to give an overview for you to have a rough idea of how this works behind the scenes. But this will be completely abstracted away for you. So let's say that a user wants to send a question to the Mech. We traditionally do this through a smart contract, but since writing data to smart contracts is very expensive, we need to minimize the amount of data we write. So what we do is when we have a big request, we send it to IPFS. For those that you don't know what IPFS, this stands for Interplanetary File System and can be thought of as a decentralized storage solution for your data. Basically, we send the request metadata to IPFS, and in exchange, we get a unique identifier, basically the data hash. Then this user needs to write this hash to the Mech contract next to a small payment. Usually, I think the current payment is one for I think for the Gnosis chain is 0.01 XDAI, so basically 1 cent of a dollar for each request. So the user writes this request and makes a small payment to the smart contract, and then the AI Mech agent service will be listening for contract events. Once they receive your event, they need to go into IPFS with this hash. Remember that only the hash lives on the contract, and retrieve the data, the underlying data that the original user had written to IPFS. Now the Mech knows what the prompt is and what the tool that needs to use to run this prompt is. So it loads the tool, it sends the prompt, and in the backend, basically what happens is that the tool will send, if this is the case for, I don't know, a ChatGPT request, the tool will send a request to the OpenAI backend and will get a response back. And then the process happens again in the other way around. Basically, the Mech will write the response to IPFS, will get a hash in exchange. This hash will be written to the smart contract, and here the user will be waiting for this chain event to happen. And when it receives the response event, it will get the hash back, will go to IPFS once again, and finally, in the last step, it will retrieve the delivered metadata. Yes, there's a lot of things happening, as you can see, but yeah, we have a library for you that abstracts away everything for you and also for agents. So let's now go into the lab session 1 and see how this works. You will need to do the same before tomorrow's call. So pay attention, and all the questions you have, please send it to the chat. We can answer them at the end of the call. What I'm going to do now is to send a Mech request using a library. This library is called the Mech client. You can install it from PyPy. I will show how to do that in a second. So the two only things you need is to basically prepare this library, installing it like this. And we also need a wallet with at least a couple of 10 cents or 3 or 4 cents for testing purposes on the Gnosis chain. That's the chain we recommend now because it's dirty cheap. If you do this on Ethereum, it will be rather expensive. So let me pull up my terminal now, make this bigger. I hope it's big enough for you guys. So yeah, the first thing I'm going to do is I'm going to prepare a virtual environment to install the Mech client library. This is optional. You can install it directly on your system, but in my case, I first want to prepare a virtual environment. For this, you can use either pipemp or Poetry. The instructions for this are on the repository. You will receive a link to it in a mail after this call. So the first thing I'm going to do is I'm going to create a new directory called Mech example. I'm going into it, and I am going to create a new virtual environment, and will accept everything by default. The only thing I need to make sure is that I am using Python 3.10 or higher. I don't want to define any dependencies, and that's it. Now I have a virtual environment. So up to this point, this was completely optional. the following thing I am going to do is basically, you can do it as well on your system directly if you prefer. I'm going to install the Mech client library. You can do it running either Poetry app Mech client, or if you are using pipemp, you can do pip install Mech client. Doing this, it's downloading the library now and installing all the dependencies. And in a matter of a few seconds, everything is installed. So now the next thing we need is to have a wallet with some funds. So there's two different ways of doing this. You might have some wallet already in MetaMask, for example, or any other solution, and you can export your private key to use it with a Mech, or you can, even better, create a new private key using the following command. When you install the Mech client, this will be available. So if you do autonomy generate key, I'm going to generate a private key for Ethereum. Basically, Gnosis, Ethereum, any EVM compatible chains will use the same key format. So you can run this. And now you can see that a new file has appeared here called Ethereum private key.txt. So I'm going to show for testing this private key. You should never do this you should never share your private key with anyone, but I want you to know what this file looks like. And since this is a burn key, basically what we have inside is something similar to this. You will have a unique hash there that starts with OX. This is important because sometimes whenever you export your private keys from MetaMask, this part won't be there. And either way, you should create a TXT file called Ethereum _private _key.txt that contains something like this. If the OX at the beginning is missing, please add it. And you also want to make sure that there's no end line or new line at the end of the private key, right? So the next step would be to send some XDAI, maybe, I don't know, 5 cents or so, to this address. I already have some private key with a few cents prepared for testing this. So what I'm going to show you now is what the repository, you will receive a link to this repo after the call. All these instructions, all these things I am running now are here listed, and basically show you how to prepare the virtual environment, how to install the library, how to handle the keys, and how to, maybe this is too small, how to interact with the Mech. Basically, the main command that you need to use is mechx interact, and you will need to pass several things to this command, namely the prompt and the agent ID. I will talk about this in a second, but there's here a list of other options. Let me copy an example and we can go over all the options that I'm going to use. For example, I'm going to copy this command from this example. So let's see what a Mech request looks like. So as said before, we start saying mechx interact, and then we need to pass a question or a prompt or whatever we want to ask to the Mech. For example, I'm going to modify this and say, write a short poem about autonomous agents. Now, there's here a number 6. What is this number for? Basically, we can have multiple mechs deployed to different chains, and each one of them is identified with a number. I know that number 6 is the mech that's deployed on Gnosis, but if you want to know which numbers you can use, you can go to the Mech repository. This is the Mech repository on GitHub, and at the very bottom of the file, you will find this table with all the mechs deployed on all the chains. And you can see that for Gnosis, which is the chain I'm using for this example, the agent ID is 6. If you are doing this for, I don't know, Zillow, you would be using number 2. So yeah, we are going to stick with 6. Then we need to pass the private key. In my case, I have the key on this file here, Ethereum private key on my home folder. So that's what I'm using for the path. And then we need to specify which tool we want the Mech to run this prompt against. For example, here we will be using OpenAI GPT 3.5 Turbo. There's a bunch of other different tools that you can find in the same repository of the Mech. If you go, for example, to the packages folder, there's a bunch of people here adding more tools by day. For example, in Valory, we have developed several tools. So if we go into Valory and then all the tools are inside the customs folder, you can see that here you have native transfer request, OpenAI request, prediction line chain. There's a bunch of different tools that you can make requests to. I'm going to stick with OpenAI GPT 3.5 Turbo. And then there's some other optional flags here that I'm going to stick with. The first one is I'm going to select Gnosis chain for the interaction. I could use Zillow or any other chain where the Mech is deployed. And there's 2 different types of confirmation. One is off chain, one is on chain, but we usually tend to use the on chain one. So I'm now going to run the command, and we are going to see several messages on the screen. We have first the confirmation that we are performing these Mech requests on Gnosis, and we are sending a request. And the first thing that happens is that we, as said on one of the previous slides, is that we have uploaded our request to IPFS. So if I click here, I go into the IPFS gateway from Valory, and I find here the prompt I have sent, which is write a short poem about autonomous agents, the tool I have selected, and then an unique identifier called nonce has been generated for me. This is the number or the ID that will identify my request. Then, after the prompt has been uploaded, it has been turned into a transaction. So I'm going to click on the transaction. I will be bring up to Gnosis scan, and I can hear that there's a successful transaction coming from my test address to the address of the contract that holds basically all the smart contract functionality for making requests and responses. Here you can see the payment. I have paid 1 cent for this request. And the last thing is interesting here in this transaction. Whenever I go to the logs, I can see that one request event matching my request has been emitted. So now need to wait until basically the Mech listens for this request and sends a response back. This can take from 30 seconds to 5 minutes or so, depending on what the load of the Mech is. And one way of checking what's the state of your request is basically going into the, let me reload this because there's a lot of, this is the place where all the requests can be seen through a front end. Let me get my request ID. I am going to copy the last part of the ID. And here we are. So this is my request. This is my address as a sender. The request data can be found here. This basically is the same thing I showed you before. It's my request metadata, and then we already have some delivered data. This means that the Mech has already sent a response back. So if I click here, I go to IPFS, And this is the response that the Mech has sent. If I go back to my terminal, there we go. The Mech client has already detected as well that there's a response. So it says basically that the data has arrived. It shares a link to that data. And this is what we get from the Mech. Some fields including the request ID again, and here's the result including a short poem about the autonomous agents until here. And then there's a bunch of other data and metadata that is not really relevant for this. You can see that includes like the tool that has been used, like OpenAI GPT 3.5. But here's our little nice poem about autonomous agents. So this is how we interact with the Mech using the Mech client. Let me go back to my slides. There we go. So yeah, basically, this is all for the lab session. The idea now is that you go and try to replicate the same thing yourself before tomorrow's call. The idea is that you go and install the Mech client, you get a private key with some funds, and you send a request similarly to this one, following the instructions on the Mech client repository. And we really want you to do this because tomorrow we will talk about a bit more in detail about what a tool looks like how the code looks like. And we will start implementing our own tool. The idea is that you can implement a tool at the same time as I will be doing here on the screen. And by the end of the day, we have at least a basic version of a simple tool that you can then integrate into the Mech. Then on the last day, we can finish that tool, make it a little more, make it a little bit more interesting, and we will show you how to mint your tool. So you basically get an NFT, like a property certificate of that tool, that you can use that to receive that rewards in the case that someone decides to donate to a service that uses your tool. So I think that's it for the lab session, and we can now move into the Q&A. I always click the wrong button. So I think we already had some questions here a bunch away, but let me check. Abhishek, can agents interact with smart contracts as well? So yes, basically agents can interact with contracts, also databases. There's no limitation. This basically is Python code. So whatever you can do with Python, you can do it with an agent. Agents are not running on chain. They can create transactions on chain. They can interact with smart contracts and so on. But agents themselves are completely off chain. The good part is that whenever you have a multi-agent service, you can have, let me go back to here. When you have a service like this composed of different agents, you can treat this as a mini blockchain in the sense that agents can reach consensus on what needs to be done. And if what the service needs to do is a transaction, then agents can reach consensus on that transaction and interact with a smart contract or just send some funds or wherever. So important to know is that agents are completely off-chain, but they behave when you run it in a multi-agent setup like this one depicted here. They can be thought of as a mini blockchain. So another question is, what if the Mech doesn't service the request? Is the payment refunded? No, as far as I know, that's not the case. But the good part is that since all the requests happen on chain, the mech, even if the mech were to go down, I mean, for some reason, all the different agents die. This, of course, is one of the benefits of having multiple agents running the same thing. Some of them can die, and the multi-agent service will still be running. This is what we call what's called fault tolerance, and that's why we are running all these services in this fashion. But even if the hypothetical case that all the agents died, and the mech would stop serving requests, as soon as the mech is brought to life again, the request won't be lost because the request lives on the blockchain. So the next thing the first thing the mech does as soon as it's online is to go to the smart contract, retrieve all the chain events that have not been served yet, and will send the response back. Of course, this is not ideal because maybe you have been waiting for, I don't know, half an hour, and that response might not be useful for you already. But yeah, just to let you know that this response will be always responded, even if it's very late. Does Mech has a testing version like DevNet tested on Solana? I don't think I can answer this right now, but I don't think we have a Mech deployed on Solana. No, we only have it on. Let's check on the Mech repository. We have it on Gnosis, Arbitrum, Polygon, Base, Silo, and Optimism. And there's no, as far as I know, there's no testing version of them. All the requests that we do are on prod, basically. But since you can use a very cheap chain like Gnosis, yeah, at most you will be spending like 1 cent per test, so shouldn't be a problem. And why did this transaction fail? Someone is asking, is this, James, is this a transaction related to a request? Let me open the transaction. Right, yeah, so let me show this. It seems, how did you do this transaction? Because this does not look, were you running the Mech client with this? So here it looks like you ran out of gas. So one thing that can happen sometimes, and let me check whether you have funds. Yeah, you have enough value here. So one thing that can happen sometimes is that the gas cost skyrockets because the chain is overloaded. Maybe a lot of people is using the chain now. So what the library does whenever you run this command is to try to estimate the gas costs of this transaction. And I think by default, it uses 100K whale. But if for some reason the chain is really loaded, that might not be enough. So you might need to change the default gas amount. And you can do this using this variable here. This is on the Mech client README repo. So I remember, yeah, this is it. You can do this. Get this environment variable and run this command. Export my gas limit. I want to set this to 200,000. And now try the command again. This should make the transaction pass. But maybe, yeah, this is because right now we are at this time of the day, usually chains are more loaded. But anyway, if you want to try this, yeah, this should make it work. You have another error now. What were you running? What were you running when you got this error? I see. I think the format of your key is not correct. Remember what I said at the beginning about this? Your key should look like this. Like start with OX and not have any end line at the end. For example, if let me open this with a traditional code editor, so you can see it. Yeah, this is what my key looks like. You can see that there's no end line. If I do this, this will fail because it will detect that there's an extra byte at the end. And I think if you remove the OX will fail as well. So please try that first. If that does not work, please ping me again. You can go into Discord or support. You can tag me on the dev support channel, and I will gladly help you there. So I think that's for today. We have no more questions. So thank you for coming. Remember to, please do this, try this at home before coming tomorrow for the next session, same time. And yeah, that's it for today. I think, Caroline, I think we can wrap it up.
Thank you very much, David. Thank you for everyone that is here in this call. As always, as David already said, anything you need, any questions, don't hesitate to reach out, and we are here to support you. And see you tomorrow at the same time.